Hello everyone, my name is Andrew, and welcome to USCO, or USA Computing Olympiad. It's really fun. It's basically solving problems with using programming. It looks great on college applications, and I've been doing it for quite a while now. It's really fun. It's for anyone that's really interested in problem solving and computer programming. So let's just jump into it. So today we're going to be taking a look at the bronze contest. We're going to be taking a look at the 2017 to 2018 season. We're going to be doing the February contest today, and let's jump in. So we're just going to scroll down to the bronze division, and let's click the first problem, teleportation. Now, if you didn't know, most or all of the USCO problems are based around Farmer John and how he hassles his farm and his cows. So, therefore, most of the lines in the first few paragraphs are comedic and funny. They're not meant to help you in your thought process. And let's just jump into it. So, if we start reading, it says, one of the farming chores Farmer John dislikes the most is hauling around lots of cow manure. So this line, as you can see, it's comedic, it's funny, and it has nothing to do with our thought process. It's just to provide context to the problem. So let's keep reading. In order to streamline this process, he comes up with a brilliant invention, the manure teleporter. Instead of hauling manure between 2 points in a cart behind his tractor, he can use the manure teleporter to instantly teleport manure from one location to another. Alright, so Farmer John, he's got the sick teleporter, and he's going to teleport manure from one location to another. And therefore, he doesn't have to haul it from point A to point B. Let's keep reading. Farmer John's farm is built along a single long straight road, so any location on his farm can be described simply using its position along this road, effectively a point of on a number line. So we have this statement where it says that Farmer John's farm is basically a number line. So we want to map out our thinkings here. So let's just put up a workspace. You can literally do anything. I'm going to use GeoGebra. GeoGebra is basically a graphing calculator and a workspace. I use it as a workspace. And basically you can just delete the grid and you have this number line here. Alright, let's keep reading. A teleporter is described by two numbers, x and y, where manure brought to location X can be instantly teleported to location Y, or vice versa. So Farmer John, he's going to go to a teleporter, which is described by 2 points, X and Y, which can teleport to each other. You can go to X and teleport to Y, or you can go to Y and teleport to X. So if we just have a number line here, and we just plot 2 points, let's just say the teleporter starts here, and the teleport ends here. Farmer John can start at 0, move his manure to point A, and teleport to point B. Simple as that. Alright, let's delete this and keep reading. Alright, so Farmer John wants to transport manure from location A to location B. So his starting location is A, and he wants to get the manure to location B. Let's keep reading. And he has built a teleporter that might be helpful during this process. Of course, he doesn't need to use a teleporter if it doesn't help. If you're kind of confused about this, let's just say Farmer John wants to get his manure from location A, or right here, to location B, or right here. And let's just say that location B is right. Let's just say that the teleporter is right here, C to D. So what's the point of using the teleporter if Farmer John can simply haul his manure to location B without hauling it to location C, which is even farther away? There's no point. There's no point. Farmer John can simply haul his manure to location B and be done with it. He doesn't need to use a teleporter. That's just hauling it more distance. Let's keep reading. Okay, so they give us this input format, which is how they're going to give us the data in which we're going to process through our code. The first and only line of input contains 4 separate space-separated integers, A and B, describing the start and end locations, followed by X and Y, describing the teleporter. All locations are the integers in the range 0 to 100, and they are not necessarily distinct from each other. Alright, so they give us these 4 numbers, and let's just work out this test case first. So A and B are 3 and 10, so Farmer John wants to haul his manure from point 3 to point 10. And they also give us the teleporter A and 2. So Farmer John can haul his manure to 8 and teleport to 2. Or you can haul his manure from point 2 and haul it to 8. And in this case, our sample input is 3. So let's just graph this on our number line first and work from there. Alright, I have graphed all the points given by the sample input on a number line. So A and B are at 3 and 10, like so. And X and Y are at 8 and 2. So if we look down, they give an explanation of their solution. So the answer is 3. So in this example, the best strategy is to haul the manure from position 3 to position 2. So Farmer John is going to take his manure and haul it from A to Y first. And then teleport it to position A, and once he reaches Y, he teleports to position X. And then haul it to position 10. So he goes from X to B, which is a total distance of 3 minus 2 is 1. And 10 minus 8 is 2. So a total distance of 1 plus 2, which is 3. And that's all they give us. So now we need to find all the possible cases in which the teleporter can be utilized or not utilized. So the first case would be Farmer John not using the teleporter at all and just going straight from A to B, which is it could be the minimum distance if the teleporter isn't anywhere near where Farmer John is trying to go. However, it could also be that the X teleporter is closer to A, and he uses the X teleporters to go to Y, which then goes to B. So that's our second case, using the X teleporter first. Or the X teleporter could be closer to Y, and the X teleporter is closer to B. Or sorry, the Y teleporter is closer to A, and the X teleporter is closer to B, sorry. So that's our third case. So let's just map this out using our notes. So let's just put some text here. So our first case would be, Farmer John doesn't use the teleporter at all. 2. Farmer John goes to the X teleporter first. And number 3, Farmer John goes to the Y teleporter first. Alright, we put that there, and now we can start coding. Alright, welcome guys to my IDE. I use IntelliJ. You don't actually have to use IntelliJ. You can use Eclipse or NetBeans, whatever you like. But I use IntelliJ because I think it's simple and the debugger is really useful. So I just simply created a new project using File New Project. I'll put a description down below if you want to use IntelliJ. It's a free download. So you just click File New Project, and within that project there's a source file. You right click that, and you press Java class. I named this Java class teleport as that's what the input format is. Sorry about that. That's what the input is. And let's just like this. That's how I organize my files. Alright, if we open up IntelliJ again, you can see I defined a main class called teleport, and I imported the Java IO, which allows us to use a bunch of constructors. And you also have to, I also put a main function that throws IO exception. So since we're going to be declaring a bunch of constructors in this USICO format, we're going to have to throw that exception, or else it's going to generate a bunch of errors. And let's get started. Alright, so we need a function to read in our input. You don't have to write this out every time. I just copy and paste it from earlier projects, but I'm going to write it down this time so you can learn it. So it's just going to be buffered reader. It basically reads in our input. I'm going to name it BR for the simplicity, equals new buffered reader. And we're going to declare a new file reader within the buffered reader. And if we write our in statement here, and if we go to our USICO problem, we can see that's called teleport.in, so that's exactly what we're going to put. So as you can see, as soon as we put that, they give us like a little shortcut. This is file name, and that's like to signify what our file is called. So it's teleport.in. And then we also have to print out or return some sort of input, so that we're going to use print writer for that. And we're going to call it PW for the simplicity again. Equals new print writer. And within this print writer, we're going to declare a new buffered writer, which is going to basically print out our output. And then we're going to declare a file writer within the buffered writer. And this is where we're going to put our output file, which is called teleport.out. Sorry for my caps lock. And we add a semicolon as we're coding in Java. Alright, now that we have our input functions down, we just need to somehow read in the input character by character. So we're going to just declare 4 variables, but how do we read in all these characters one by one and put them into variables? So luckily we have this handy dandy function called string tokenizer. So we're just going to call it string tokenizer, st for the simplicity again, equals new string. So this string tokenizer is going to utilize our BR, or our buffered reader. So we're just going to do br.readline. So as you can see, oh yeah, one thing about this is that this function is camel case, so the L is capitalized. Alright, now that we have our string tokenizer, if you didn't know string tokenizer, it tokenizes a string into like different individual tokens, and all you need to do is it's a function called st.nextToken, which reads in this input one by one, so that we can plug them into variables. So the first variable is a, and then it's b, and then x and y. So we're just going to declare these variables right here. So they're obviously going to be integers. So in x or in a equals st.nextToken, which is going to be the first one. In this case, 3. Sorry about that. And our next integer is going to be, we also have to put integer.parseInt as the string tokenizer reads in the input as a string, so we need to convert these to integers. Alright, if you feel really lazy and you just want to declare 4 variables really fast, you can just copy and paste and change the letter. So what this is, sorry about that. So what this is doing is that it's always getting the next token, and we just rename them. So A, B, and then X and Y. Alright, so now that we have our input and we have our variables declared, we need to do something with these variables, and we need to get the answer somehow. So we're just going to go back to our notes over here. So our first case, Farmer John doesn't use the teleport at all. So in that case, that would just be the positive difference between A and B. So we're going to declare a variable for our distance. This is what we're going to return later. And now we declare a variable for our hall, in which Farmer John doesn't use the teleport at all. So we're just going to name this hall, and it's going to be the positive difference between A and B. So therefore, we can't have it negative, so we're just going to use that absolute value function. So it's going to be math.abs, and it's going to be A minus B. You can also do B minus A if you want, but I'm just going to use A minus B since I like it in alphabetical order. Alright, now we go back to our notes. We have to use the X teleporter first. That's our second case. So in this case, we're just going to call it X teleport, or I'm going to call it XTP. And it's going to be, we always want it positive, so it's definitely going to be math.abs, or math.absolute value. Alright, on what to put here. So let's go back to our notes. If we just say I want to use the X teleporter first, sorry about that. We're just going to move X closer to A. So Farmer John's going to go from A to X, and then he's going to teleport to y and then go to b. So therefore our distance is going to be between a and x and y and b. And always make sure that it's positive, as we don't want to be dealing with negative numbers here. So we're going to nest more absolute value functions within the original absolute value function. And it's going to be math.abs a minus x, like we mentioned before, plus, as this is the sum, math.abs b minus y. And for the second one, we're going to go to the y teleporter first. So our y teleporter is going to be closer to, is going to be closer to our a. So we're going to call it yTP. And instead of a minus x, we're going to do a minus y. And instead of b minus y, we're going to do b minus x. Okay, now that we have our three cases, they want the minimum. They want the minimum distance that Farmer John needs to haul the manure in his tractor. So now we just need to take the minimum of all these three. How do we do that? Well, luckily we have this function called math.min, or it takes the minimum of two integers. So we have a slight problem here. If we have three cases and only two places to plug it in for math.min, what do? So we can take the minimum of two of them first, and then take the minimum of the resulting two. So we're going to take math.min, we're going to do haul as one, and then we're going to do another math.min for xTP and yTP. And also we need to set this value to distance, as that's what our final result is going to be. Alright, now that we have our supposed answer that I'm pretty sure is correct, we're going to print it out using the pw.println, the thing that we declared earlier. And this is all we're going to put distance. This is quite a simple solution. It's not that hard. But later, when we get into harder problems like that use data structures, we're going to be writing a lot more code. So after this, we're just going to close two of the functions, or else they're going to keep running. So we're going to close pw and as well as br, and that should be it. And now we're just going to test it out. We can rename these to test. And all you need to do is declare new test files within the IML. Just right click it, press new, and press file. You name it test.in just to test it. I already declared mine. And now we can just copy our test data, or our first test case that they offer, and we plug it in here. I already did. We can just do that again. Now we run it. So it's running now, and then the process finished with exit code 0, so there aren't any errors. And if we check test.out, our result is therefore the 3. So now that we have our example test case passed, we can just plug it in. I'm going to sign in real quick. I go back to our contest. Oops, wrong thing. As you can see, I already solved this problem before, but I'm just going to plug it in again. So we press Java, that's what we're coding with. And I put my file here for easy access, so I can show it to you guys. If you need help finding your file, you basically go here and you look at you widen this, and you look where your file is through these words, and then you just put it in a place where you can easily access through by clicking this, and mine's right here. So we're just going to submit it, and they have a grading server that's going to grade our solution for us. So hopefully the solution passes in satiable time. Oh, sorry. You always have to make sure that these are named the input and output files they give us. In this case, teleport. You can find those names right here. Teleport.out, teleport.in, and we can just right click back, and our original thing is right here, and we can rerun it. our first test case has passed, and more have come. And boom, we just solved one of our USCO problems. So thank you guys for watching. This is the end of the video. I hope you subscribe and like. Don't worry, our videos will get better. And yeah, thank you for tuning in. See you around.